title is the Pythagorean Theorem, and we're going to start by drawing a right triangle. So a right triangle, we're going to put a little box to show that it has one angle that's 90 degrees, and then we're going to label the two sides that are next to the 90 degrees, A and B. The side that's opposite the right angle, we're going to label with C. Okay? So a right triangle has two sides that are called legs. They're the sides that are next to the 90 degrees. Okay? They're the first two sides I had you labeled, A and the B. Okay? Then we have only one side that's called the hypotenuse. And it is always opposite the 90-degree angle. Okay? In this case, it's C as in cat. Okay? So most of you know the Pythagorean Theorem. You could raise your hand and give it to me. What is it? Right? A squared plus B squared equals C squared. Okay, so you've got three sides. One of them is usually missing, whether it be one of the legs or whether it be the hypotenuse. And you plug in the two that you know, you solve for the one that you don't know. Okay? You just got to make sure it's in the right spot. So if it's one of the legs, it can the x can go here or here. But if it's the hypotenuse, then the x has to go here. Okay? One other way to think of the Pythagorean Theorem instead of with a squared plus b squared equals c squared is to think of it as leg squared plus leg squared equals the hypotenuse squared. Okay? All right, so we're going to do a couple. First one we're going to look at, we'll title it example number 1. We've got a right triangle. We know that because it has a box. They can also tell you it's a right triangle. And so you want to start by writing down the Pythagorean Theorem. It's okay, I'll get it in a minute. A squared plus b squared equals c squared. Oh, that's awesome. Okay, so we need to find which of the three is missing, one of the legs or the hypotenuse. Okay? So this x, is it a leg or is it a hypotenuse? Hypotenuse. So if it helps you write HYP, that means the other two are legs. They need to go in for the A and the B. So we're going to say 2 squared plus 6 squared equals x squared. If you want to leave it as C and solve it for C, that's fine. I just prefer to put in x for the missing side, but it doesn't really matter what variable you use. Then you just take your calculator, you square the 2, you should get 4. You square the 6, you should get 36. And then you get, add those two together, so you'll get x squared equals 40. Once you get to x squared equals 40, you need to do the inverse operation of squaring, which is square rooting. So you're going to square root both sides. From here, you want to do whatever the directions tell you to do. The directions are going to tell you one of two things. Either going to tell you to give your answer as a simplified radical, or they're going to tell you to round to the nearest whatever, tenths, hundredths, thousandths, millions, whatever. So in this case, we're going to do hundredths with a little th on the end there, hundredths. Okay, that means decimal point. So if you want to round to the hundredths, how many numbers after the decimal point would you have? 2. So like if you have a sub number in front of the decimal point, you're going to have 2 numbers after the decimal point, which means you look to the third number, and that determines whether that number stays the same or rounds up, okay, depending on what it is. All right, so we're going to do both. We're going to simplify the radical of the square root of 40, and then we're going to round to the hundredths using a calculator. Okay? All right. So you're going to take the 40 that's under the radical, and you're going to do what's called the prime factorization. Okay? So this is where you do the little tree thingy, or some of you are really good at looking for perfect square factors. It just depends how good you are with multiplying. Okay, so since 40 is even, we know that 2 goes in there, and it goes in there 20 times. 20 is also even, so 2 goes in there 10 times. 10 is also even, so 2 goes in there 5 times. Okay, so the prime factorization of 40 is 2 times 2 times 2 times 5. Okay, so once you have your numbers that are part of the prime factorization, you're going to look for pairs. So I have a pair of 2's. You multiply 2 times 2, and then you take the square root of it. You're taking the square root of 4, which is 2. So you're going to take out one of those and put it in front of the radical. Anything that does not have a pair, like this leftover 2 and this leftover 5, don't have a pair, so they have to stay under the radical, and you just multiply them together. So 2 times 5 is 10. So the simplified radical here is 2 rad 10. So the hypotenuse is going to be 2 rad 10, and this one was in inches. If it doesn't specify unit, just say units or whatever. Okay? So if they want you to simplify the radical, that's how you get the answer. If they want you to round to the nearest hundredth, you're going to take your calculator, you're going to turn it on, and then you're going to use the square root button. So right above the x squared key in light blue on this calculator is a square root. So I have to hit shift or second, and then on the screen should appear the square root symbol and then parentheses. So that's where you type 40, close the parentheses, hit equals. So on your calculator, you're going to get 6.324555532. Whoa. Do the directions want you to write down all those numbers? No, they want you to round to the nearest hundredth. So the 6 is definitely going to stay because it's in front of the decimal point. Then we need the first 2 numbers after the decimal, but the third number after the decimal is what determines if it rounds or if it stays or rounds up. So if it's 0, 1, 2, 3, or 4, it stays. If it's 5, 6, 7, 8, or 9, it rounds up. So in this case, is it going to stay or round up? Stay. So as a decimal, our answer is, and notice I'm not using a regular equal sign, I'm using a wavy equal sign. Why? Because we're rounding, right? It's approximately 6.32 inches. These numbers do not look even close to the same, but they are. If you took your calculator and typed in 2 rad 10, you'd still get approximately 6.32. Okay? Any questions on example number 1? All right, example number 2. Move that up. So for example number 2, we clearly have a right triangle because it has the little box. So we're going to write the Pythagorean theorem, which is a squared plus b squared equals c squared. And the easiest way to start it is to look for the side that's missing. The side that's either labeled x, or it's blank, or question mark, however it's indicated to you. Okay? So I found it right here. Is that a leg or a hypotenuse? If it's a leg, I'm going to recommend that you always plug it in for A, because you have a choice of A or B. My recommendation is to always plug it in for A. So we're going to have x squared plus 24 squared equals the hypotenuse, which is 26 squared. Okay. Then we're going to do some calculator work. So you punch in 24 and square it, you should get 576. Punch in 26 and square it, you should get 676. Subtract the 576 from both sides. You get x squared equals 100. The inverse operation of squaring is square rooting. So when you square root both sides, you get x equals what? 10. We don't have to simplify a radical. We don't have to round to the nearest hundredth. It comes out to a nice whole number of 10, okay? That makes this something called a Pythagorean, or Pythagorean, however you want to say it, Pythagorean triple. Okay? Pythagorean triples are basically when you have three sides of a triangle and they don't have radicals and they don't have decimals. So this one right here, if we plug 10 in, we have 10, 24, 26. That's a Pythagorean triple. It's actually a multiple of another triangle that is 5, 12, 13. Does anybody know the most famous Pythagorean triple? Anybody's work construction ever built a house or a room or helped pour concrete or something?
1, 2.
Good guess. It's actually 3, 4, 5. So if you have a measuring tape, right, and you measure one direction 3 feet, you measure another direction 4 feet, and then you go diagonally 5 feet, you make a perfect right triangle, okay? So that the corner of your room is a perfect 90 degrees. So you don't accidentally get 87-degree angle in one of your corners, right? You want perfect 90 degree. So you use a 3-foot, 4-foot, 5-foot triangle, and it gives you a nice corner in all of your rooms, okay? Some other Pythagorean triples are 7, 24, and 25. Another one is 8, 15, and 17. Okay? Finish copying those down.